Low carbon intensity hydrogen, say that 10 times fast, is part of the clean energy mix. On this episode of the Reimagined Energy podcast, I'm joined by Mark Kirby, Senior Advisor of the Canadian Hydrogen and Fuel Cell Association. Coming up in just a sec. Welcome, Mark.
Welcome.
Thanks for joining me today. You're with the Canadian Hydrogen Fuel Cell Association?
That is correct.
I got that all right. That was wonderful.
CHFCA, that's right.
Exactly. There we are. Now, I'm really pleased to have you on the podcast because I'm really curious about hydrogen and how it works and what it is. And I guess a great way to start things off is explaining the process of making low carbon intensity hydrogen.
Okay, delighted to do that, and really pleased to have the opportunity to talk about this, Maria, because it's hydrogen is going to play a bigger and bigger role in our lives, and so it's very important that people begin to understand a little bit about it, how it's used, how it's made, and some of the benefits that it can bring. So first of all, how do you make hydrogen? Well, hydrogen is a very simple element. It's actually an energy carrier. So what you're doing is using it to take energy from a source, whatever that source is, to a use point, whether that be a bus or a truck or heating a building. So to make that hydrogen, you can do it many ways. You can take, and the most basic way is to take water. And water is made up of hydrogen and oxygen, H2O. And if you put energy into that, you can pull that apart, and you wind up with hydrogen and oxygen. And the energy is nicely stored in that hydrogen. And then you can take it and use it in other places. The nice thing about it is however you use that hydrogen, whether you use it to heat a home by running in a furnace, whether you use it in an industrial process, whether you use it to run in an internal combustion engine, or whether you use it in a fuel cell to generate electricity, the only thing you get out of that process is water. It goes back into that water. So that's one way you can do it, is to take water and pull it apart. Now, how you do that typically is with something called an electrolyzer, and it requires electrical power. Now, as long as that electrical power is generated from a clean source without emitting carbon, then the resulting hydrogen is clean.
You know, you mentioned clean hydrogen. So what goes in the making of that?
So the definition of clean hydrogen and or low carbon intensity hydrogen is just exactly that. Is that from well to production point, or where, the source to production point, there is little or no carbon dioxide emitted into the atmosphere or the greenhouse gases. So the key thing is that when it's in its overall production process, that there's very low emissions of CO2. Now, so if you do that with water, splitting water and using clean electricity, there's little or no GHGs emitted. So that is very much clean hydrogen. And if you use renewable sources to produce the electricity, then it's what's called green hydrogen or renewable hydrogen. Now, that's great, but there are also other ways to make hydrogen, and some of them are very cost competitive. That is to tear apart hydrocarbons. It's, as by the word says, hydrogen and carbon are mixed together in things like natural gas and oil, even in things like biomass. So if you can also reform those to release that hydrogen, getting you that energy. But the challenge here is, what do you do with the carbon part of it? Now, if it's emitted as CO2, then it's not considered clean hydrogen. It is what they call gray hydrogen or black hydrogen or brown hydrogen. But anyway, it's not considered clean hydrogen. But if you do that and manage that carbon, either keeping it as elemental carbon, as like carbon black, which is a useful product, or by taking the CO2 that's produced and storing it, sequestering it permanently in another location, and underground or wherever, then it's also considered clean hydrogen because there are no net GHG emissions. Now, the other key thing is you got to make sure that your source and your production of your whatever fossil fuel that's used to make it or biomass also doesn't release GHGs, because that counts. So
Right.
you got to make sure the whole chain from start to finish is low or no carbon intensity. The good thing is there are standards that are being developed globally to measure that. There are ways of doing that that have very, very low carbon dioxide emissions. So it is very possible to make clean hydrogen from all sorts of different energy sources. And that's a good thing, because, as we'll talk about, we're going to need lots of hydrogen, and we need to get it in as cheap a way as possible. We need to get it from the energy sources that are available out there, and all the energy sources that we've got. So it's a good thing that we can make low carbon intensity hydrogen from many, many different ways.
Well, I was doing my homework for hydrogen. You can't talk about hydrogen without talking about fuel cells.
Yeah.
And I was trying to find out what the correlation is, and you could probably explain it way better than I ever could.
Right. So what we're using, what we want to try and do is, when we're using hydrogen, it's to, is part of our everyday processes to heat our buildings, to run our vehicles, to do our industrial processes. One of the applications that you can do with hydrogen is to run it through a device called a fuel cell, which was developed in Canada actually by Ballard Power over 40 years ago, and has been in Canada is a leading country in the manufacture and sale of fuel cells around the world. What fuel cells do is they take that hydrogen and they react it with air in a very controlled way, much like a battery, and they produce electricity. Now, the good thing about that is you can use those fuel cells in a number of different applications. You can use them, for example, in a building as backup power, or in a big data center to back up your power, or even as a source of baseload power for certain applications in other areas. But the big area that fuel cells enable is transportation. Transportation in all its forms. Transportation in aviation, in shipping, in marine, in rail, you name it. And that's because you can combine a fuel cell with a battery in a hybrid system, and you use electrical power to run your vehicle, just like any EV out there today. But instead of having to charge that battery, the fuel cell provides that charge and charges that battery up, and also works with that battery to provide you your maximum power. And to refuel that vehicle, you can put hydrogen into a storage tank on that vehicle to run the fuel cell. So now, instead of being tied to having to recharge your battery, you can very quickly and conveniently refill it with hydrogen. And the nice thing about that is that storage system, that tank of hydrogen, has a lot higher energy density. In other words, there's just a lot more energy in it than in an equivalent battery. It's also a lot lighter. And so that means you have a vehicle that is light, can be refilled quickly, and has better range. And now that means that we can have electric vehicles that compete in all transportation applications, not just in select ones, but now it can run heavy duty trucks, it can run trains, it can run even airplanes and your car. But your car may not be the primary area we use fuel cells. You may be perfectly fine with a battery, but there are many, many, many other transportation applications where that combination of fuel cells and batteries will enable us to get rid of internal combustion engines and running on fossil fuels entirely.
Well, can fuel cells be used in homes, or what are they best used?
So the most common application which people are most excited about for fuel cells is in the transportation area, which we talked about. But yes, they certainly can be used in homes. In fact, I worked for many years with a joint venture in Japan doing residential cogeneration. So we had fuel cell systems in there that produce both heat and power for houses, very small compact systems. They have some interesting potential and may have some very good fits around the world, but they also require us to get a hydrogen infrastructure in place to fuel them. So that's going to take a bit of time, but they are a very interesting way to complement the turning our buildings and our homes into net zero buildings. So it is an interesting and very promising area. In addition, some industrial applications, and one of the biggest one is, as mentioned, is in data centers. Data centers have huge power demand,
Hmm.
and they need that to be very, very reliable. And fuel cells can very nicely back up those power demands in a clean way instead of having masses of diesel generators sitting on hand to back them up. So that's just one nice application that's coming along quite quickly. But say the most exciting one though is in the area of transportation.
Transportation. Yeah.
But I will say hydrogen is a very flexible gas, and it doesn't. Fuel cells are not the only way it can be used. So you can also run hydrogen into an internal combustion engine. And there's a number of companies, Honda, Toyota, Ford, and others that are working on hydrogen internal combustion engines, which have advantages because we already have the whole supply chain in place for internal combustion engines, and the technology is well known. So now we can run internal combustion engines on hydrogen. And again, all we produce out of them is water vapor.
Huh.
You can also run hydrogen into furnaces or stoves. So your barbecue can run on hydrogen and be net zero. So it's a very, very flexible gas, and there's a lot of applications and opportunity where we can help ourselves decarbonize by using hydrogen. Now, it's not going to be the entire answer. I want to make that very clear. We're not at all pretending that hydrogen is going to be the silver bullet, as they say, that solves all of our world's problems. But it is going to be a very important part of the mix, and we're going to need a lot of it. And it's going to complement electrification. It's going to complement biofuels. It's going to complement carbon capture and sequestration. And we need all of those arrows in our quiver, shall we say, to be able to actually get and solve our GHG emissions problems and achieve net zero. So I'm very excited by the opportunity and the excitement. It's an enormous business opportunity for our members in the Canadian Hydrogen and Fuel Cell Association. We're seeing investment, we're seeing sales ramping, we're seeing huge economic opportunities, jobs, investment, you name it. and Canada is really well positioned to take advantage of that. And at the same time, we know that what we're doing is on the path to net zero, and it's going to help us in achieving those critical goals. So very exciting.
Absolutely. Oh, I love that. Sorry to interrupt here, but did you know that this podcast is a passion project of sociable media? And this is where I get to do a shameless plug for our services. Sociable Media is a digital marketing agency that works with clients in the renewable energy sector. We design websites, manage social media, run ad campaigns, write content, all that sort of digital marketing stuff. I just want to throw that in there. Now back to the podcast. But water vapor and electricity, for some reason, they don't seem to, they don't seem to mix very well. So I guess there's a lot of safety features.
That's a common concern, and one that is an absolutely excellent question because hydrogen, and people have probably heard a lot about hydrogen. They may have heard of past disasters that I won't even name, but I want to assure everybody that hydrogen has come a very long way in the past century, and it's been used safely and reliably for decades. It is a flammable gas. It's stored in a compressed state. When you produce, when you use it in a fuel cell, you're producing high voltage electricity. So yes, there are safety precautions that need to be followed. I personally have worked for over 40 years in building equipment for hydrogen, moving hydrogen, handling hydrogen, using hydrogen, and I have a great deal of confidence that it could be handled safely and reliably. And that the workers that I had with in my companies were safe in working with it. But we did that adhering to the standards and following the codes that are out there. And the good thing is that there's a ongoing work to ensure that all those safety standards are being met. And the end state is, if you look at the projections, is that vehicles running on hydrogen, for example, will actually be safer than vehicles running on gasoline. And that's also encouraging. That gives us a great deal of optimism that this is a really good solution.
How much water is needed to make hydrogen? Do you need a
Another
lot
good
of
question.
it? Yeah.
Another good question. You do need water, and you need reasonable quantities of it. As we scale up hydrogen, we're going to be needing more and more to produce the hydrogen we need. But we need to keep this in scale. It is a very, very large hydrogen plant would be an industrial demand, but still would be dwarfed by the demands that we have today in oil and gas extraction, in processing, in pulp and paper, in drinking water, in farming. So there, even though this is something that, when people are putting projects together, they'll need to make sure they have sufficient clean water available for their sources, or put in desalination systems to supply that. But it is not an insurmountable burden, and it's not going to be a staggering demand for energy. In fact, many of the countries that are most interested in producing hydrogen for export, countries like Australia and Chile, I mean, they have challenges around water today, and they recognize that they can produce the water they need for that, for being in the export business quite effectively. Canada, we are fortunate. We have ample water resources. We have low cost power. We have an abundance of renewable resources and fossil fuels. We can produce hydrogen very cost effectively and very cleanly. And we'll actually be in a very good position to be an exporter of hydrogen to help other countries to decarbonize their operations.
You had mentioned earlier about desalination. I guess that's
Desalination, yeah.
There you go. That is, I guess, applying salt water or ocean water and getting the salt out of it.
Absolutely, yeah. Desalination is a process where you can use salt water or brine and clean it up, basically extract the brine from it and produce fresh water, and that fresh water to be used for your electrolysis process. So it is and in fact, there are electrolysis technologies out there that are starting to work on using salt water directly, but today the need is for pure water and desalination.
Where's the use of hydrogen being explored throughout Canada? What provinces or cities or industries even in Canada are really starting to explore the use of it?
Good question. It's a very broad potential applications, but there are certainly some applications in some regions that are leading today, which is kind of exciting too. So from an applications point of view, where we're seeing hydrogen being used today is in industrial processing, producing chemicals, producing fertilizers, producing various other products for our use. And there are existing users of hydrogen, and they're shifting more and more to clean hydrogen, so that they are making sure that the hydrogen they're using does not emit GHGs as part of its process. And we're seeing a huge growth of that, particularly in Quebec and in Alberta. So that's one application, and as we know, industrial processing is about 1/3 of our GHG emissions come out of that. So that's a very important one to decarbonize. The other area we're seeing growing demand is in transportation. We have fuel cell vehicles on the roads in BC today and in Quebec. And there's a lot of projects. There's projects happening in to demonstrate fuel cell buses, fuel cell trucks, and fuel cell trains in Alberta. So we're really starting to see now in Canada the start of the use of hydrogen in transportation. And I can't tell you the excitement we see from everybody from the airports to the ports in saying, okay, we want to start looking at this and seeing how we can use it. So that's the second big area. And as we know, transportation is another 1/3 of our GHG emissions, and a really critical one for us to decarbonize. The third area is in heating. And we have already got a project running in Ontario where hydrogen is being blended with natural gas to heat homes. We have projects on the books in Alberta, in BC, in the Maritimes, and in Quebec to do the same thing. So that's also starting to move forward, and is a really important area for hydrogen use. Overall, I would say that Alberta is leading in hydrogen. They recognize hydrogen as a massive business opportunity that well suits their needs, and they are investing in it, they're supporting it, and they have demonstrations and trials underway. BC has long been a leader in hydrogen. They have a center of fuel cell industry, and there is a lot of effort on getting to zero emission transportation in BC. So there's the demonstrations and the fueling stations being built here. Quebec has been producing clean hydrogen for decades, using their clean, abundant hydropower, and they're expanding that. They're expanding that to make biofuels. They're expanding it to produce additional hydrogen for liquid hydrogen for export. So those three provinces are probably leading: BC, Alberta, and Quebec. But Ontario, there's any number of projects that are being looked at, and I am very optimistic that we'll move forward in things like steel production. In Hamilton, there's some huge projects that are planned to convert the mills there to the use of hydrogen. We've got strong interest in decarbonizing the 401 corridor, one of the busiest trucking corridors in North America, and in converting and putting in place a series of fueling stations along the 401 to enable hydrogen for trucking. And other, I mentioned the heating applications. So there's a lot of activity happening there. The Maritimes, you'll be happy to know, is also a center, and that's been a really impressive growth in interest. 2 or 3 years ago, it really wasn't on the radar screen, but today, because of the recognition of the enormous offshore wind potential in the Maritimes, and
Yes.
because of discussions between Canada and Germany and other EU states, there's growing interest to take advantage of that offshore wind, which is difficult to develop just for the domestic demand of electricity, and build out gigawatt scale projects producing hydrogen for export to Europe. It's absolutely, these are huge multi-billion-dollar projects. It's an enormous opportunity for the Maritimes, and we're really seeing that the provinces are embracing this. Newfoundland, in particular, is actively soliciting proposals for projects to take advantage of their wind for export to Europe, to convert to hydrogen and convert and take to export to Europe. So I think it stands it could be a very, very large opportunity in the Maritimes if we move forward, aggressively and encourage the development of these projects. And I will put in my own little encouragement that we don't just look at the export opportunity, that we also make sure that we're taking advantage of that hydrogen for our domestic needs in the Maritimes, because that domestic demand is the early demand you need. It gives the experience, it gives the skills, it gives the intellectual property. So I really, I'm hoping, and we do hear support from the provinces, that not only do they look to develop the export potential, but they also look to develop the domestic demand to help them decarbonize and to build that industry.
It's really exciting to see how the industry is is really taking shape, and the technology is getting better and stronger, and the safety protocols are in place, and how it can be not as a competitor to batteries, but complementary to, as an additional resource. But thank you so much, Mark, for joining me today. And I felt at 1 minute there I was in my grade 9 science all over again at the very beginning, explaining hydrogen to me. I really appreciate your time, and all the best with your What is next for your association? What plans do you have?
Well, thank you for asking. So the Canadian Hydrogen and Fuel Cell Association is an industry-supported association of companies that are in the hydrogen value chain. So they produce it, they use it, they build equipment for it, and they're selling their products around the world. We've been around for 20 years, and Canada, I'm very proud to say, is one of the leaders in hydrogen technologies, and we export products to countries around the world. Um, what we're seeing ahead of us is a huge opportunity. We are seeing investment flowing in. We're seeing, companies looking for projects to develop. We see the support from the federal government, support from the provinces for the development of this industry. We're seeing the right policies and funding support come into place in Canada to make it a great place for investors to invest in hydrogen production and hydrogen use. So we're extremely optimistic. We are extremely busy. Our
Mhm.
challenges are around, supply chain issues, around labor force and getting, skilled technicians, skilled engineers, skilled scientists, all the things you would expect in a burgeoning and exciting industry. But I think we have a very great group of companies, and I'm extremely optimistic that they will be very successful on the world stage in the years to come.
Well, I can definitely sense the excitement and the enthusiasm that's in the air with all the sectors as we inch toward net zero. Thank you so much, Mark, for joining me today.
Thank you, Maria. It has been a pleasure.
I hope this episode gave you a fresh way of thinking about the applications of hydrogen and the potential for the industry. Super appreciative of Mark for taking the time out of his busy schedule to speak with me. In a future episode, I will be joined by Yvette Vera Perez, President and CEO of the Canadian Hydrogen and Fuel Cell Association. So make sure you tune in for that one. This podcast is sponsored by Smart Energy, and I'm your host, Maria McGowan. Thanks for watching and listening.